Hello students, we have a question in front of us. This question belongs to the chapter circular motion. Let's read out the question and then see how to solve this question. The question says, a coin placed on a rotating turntable just slips if it is placed at a distance of 4 cm from the center. If the angular velocity of the turntable is doubled, it will just slip at a distance of 1 cm, 2 cm, 4 cm or 8 cm from the center. So here first we need to understand that this question does not only have the concept of circular motion in it, it also will require the basic concepts of friction. So the first two basic concepts that we are going to need to solve this problem are mentioned in the first two bullet points. As you can read them out. On a turntable, the necessary centripetal force is provided by the friction between the coin and the turntable. That is the first and the foremost important statement of the question. What will provide the necessary centripetal force for the circular motion to happen? This is the first basic concept. The second thing that we must understand is at the time of slipping, the friction between the objects is limiting. So if we are not changing the system, that means the coin and the turntable, the limiting friction will always be same. No matter what conditions we are in, if we are not changing the objects, the limiting friction between the objects will never change. It will always remain same. Now, after all these discussions, all the concepts, we can start solving the problem. And now we can assume that if the turntable is rotating with angular velocity of omega, the slipping occurs at 4 cm. Now what will happen if the angular velocity of the turntable will be doubled? That is twice of omega. Let us now try to see these two cases one by one. The first case would be when the turntable is rotating with an angular speed of omega. Then the slipping occurs at 4 centimeters. And at the time of slipping, the friction must be limiting. So we can write that the limiting friction must be providing the centripetal force. So we could write that FL, the limiting friction, is equal to m omega 1 square into R1 is equal to m omega square into R1 can be written as 0.04. I have converted the centimeter into meters as we are going to solve the entire problem into SI units. And omega 1 can be replaced by omega as omega is the current angular speed of the turntable. Now for the second case, we assume the angular speed of the turntable as twice of omega. And here as well, if we assume that the slipping occurs at a distance x from the center, we could write the equation that the limiting friction FL is going to be equal to m omega 2 square R2. And omega 2 can be substituted as twice of omega and R2 can be substituted as x. And this will give us the result as 4mx omega square. That can be given as this equation 2. Now in these two equations, what we have done, we have found out the limiting friction of the system of the coin and the turntable in both the cases when the angular speed of the turntable is omega and twice of omega. But we have already discussed that the limiting friction will not change. It will remain the same as long as the coin and the turntable are used as a system. So we can directly equate these two equations 1 and 2 and we can write that m omega square into 0.04 is equal to 4 times mx omega square. Solving this equation, we can find that the value of x can be given as 0.01 meters, which can be further converted into centimeters and it will come out as 1 centimeter. Hence, we could say that if the omega or the angular speed of the turntable is doubled, the slipping will now occur at 1 centimeter away from the center. I hope you have understood the solution and the concepts used to solve this problem. Stay tuned for more solutions. Thank you very much.